26.
All right, so section 4 homework review. All right. 27. What is 27, Sydney? 47. 47 is my favorite number. We'll do 26 next. It's a long story. I'll tell you sometime when I'm not videoing the lesson. But number 47, read it.
How can we find this lesson on YouTube search?
Cotangent x
Equals negative 12 over 35.
negative 12 over 35.
Yes.
That's a wicked number.
And then it's negative pi over 2 is less than x.
Ooh.
Less than 0.
What is this telling us? No, it's in quadrant 4. Remember, negative pi over 2 is down there. And 0 is there. So we're in quadrant 4. That's what that information tells us. What are we trying to find? So we want to know we want to know those three values. Wow, that's a lot of work. Sine of 2x. Cosine of 2x. And tan of 2x. Now, if you can find one, you can find all of these, right? Probably not going to test you on the tan 2x formula. So let's just kind of consider sine and cosine for now. All right? But the important part here is noting that this is a fourth quadrant angle, right? Fourth quadrant angle, we get that from this information right here. And the cotangent is 35, negative 12 over 35. Cotangent is the adjacent side over the hypotenuse. And what mistake did I just make? That cannot be negative. That is correct. And I did say hypotenuse. Two mistakes. So that's the triangle we're working with. Right? And I need to solve for the hypotenuse. Did any of y'all do that? 12 squared plus 35 squared equals. It's 37. This is a Pythagorean triple. Wow. 12, 35, 37. Actually, it's a, because 37 is prime, that's the smallest of this Pythagorean triple family. Yeah. The smallest integral Pythagorean triple is 3, 4, 5. Okay? And then 5, 12, 13 is the next smallest one. I wonder if this one is the next smallest Pythagorean triple family. Interesting. Perhaps it is. All right, sine of 2x. Let's start with sine of 2x. Sine of 2x is equal to 2 sine x cosine x, right? So that would be 2 times the sine of x. The sine of x is negative 35 over 37. Cosine of x is 12 over 37. And whatever that monstrosity is there, if you multiply that all together, you get top times top times top, bottom times bottom times bottom. I will not give you one that's that difficult to navigate without a calculator. You will have a calculator, but just saying. Yes, you can. No. It's got to be in fraction form. It has to be the whole purpose of this is exact values, right? Exact values. Otherwise, you could take this information right here. Now watch this. It's pretty slick. You can do inverse tangent of 35 over negative 12, and that would give you the reference angle. And then you just double that value, plug it in for there, and find a decimal value using your calculator. Okay?
Can you change that into a fraction?
Sometimes you can, sometimes you can't. because it might be irrational, right? If it had the square root of 12 in it, then no, it's an irrational number. It can't be changed to a fraction. And more often than not, we do get some pretty, interesting irrational expressions for these answers. That's the purpose of exact values. Sweet Lord, it's hot.
You're right.
All right, 26 was next. And to do the cosine of 2x there, you would have to do the same thing. All right, so 26.
And the cosine of 2 theta.
Is that what we're looking for?
No.
Okay.
Equals 1 minus the tan squared of theta over 1 plus the tan squared of theta.
What are we doing here?
Verifying.
Okay. Tan squared of theta.
So it is.
All right, so on the right side, I'm going to change everything into sines and cosines. So that would be 1 minus sine squared theta over cosine squared theta over 1 plus sine squared of theta cosine squared of theta. How do we do that? How do we get rid of the complex fractions? Multiply top and bottom by the cosine squared of theta. And we could put that over 1 just to kind of be clear where everything is, right? Yeah, the cosine squareds will cancel, but you got to distribute, right? So on top, when you multiply cosine squared times 1, we get cosine squared. So in the numerator, we will have cosine squared of theta minus the sine squared of theta, right? Because this times this is cosine squared. This times this, the cosine squareds cancel, and you're just left with that. And in the bottom, we're left with cosine squared plus sine squared, which is Juan. It's Juan. Sine squared of theta. And that's equal to 1. Right? And the top is our identity. Cosine squared minus sine squared is equal to cosine of 2 theta.
I just went out the complete one.
Did you use a Pythagorean identity?
Yeah, I used like secant squared.
All right, it still works. Can I show you how that would work? But you still have to do the same trick. Are y'all okay if I erase this? All right, you still have to do the same trick. If we rewrite the bottom as secant squared.
Oh, you can't rewrite the top because it's negative. That's what I did. I made the top like the secant squared thing too. I wouldn't have.
Oh, yeah, that would be a problem.
Yeah, that's what I did.
But if you did this, you have 1 minus sine. Coach Wallace yelling on the YouTube channel here. So we still have to do that, and you still have to multiply top and bottom by cosine squared,
Sorry.
and then you still get cosine squared minus sine squared over 1, and that's so it works out the same way if you do it that way. Okay. All right. What else?
Will you do 49, 51, or 53?
You pick. 51. Spence wants 51. What is the given information in 51, and what are we looking for? Negative square root of 8. Okay? And what else is given to us? 90. That's not right. Is that 0?
I mean 180.
You said 0, Stephen. Where's Emma going?
I don't know.
She just walked out.
She's just taking her toys and leaving. Bye, Emma.
She told me she was leaving.
Don't you want to get your work?
She went to the hair shop. She ain't worried about her work.
What does that tell us?
It's in quadrant 3.
The angle's in quadrant 2. 90 to 180 degrees is quadrant 2. All right, then what? What are we looking for? What are we trying to find?
All those.
Oh, sine 2x. Cosine 2x. Tan 2x. let's just do cosine this time since we did the sine last time. But the tricky part is getting the triangle. The triangle is in the second quadrant. Second quadrant is our reference angle. And opposite over the hypotenuse.
-8 is a little.
No, it's the opposite over adjacent. I keep doing that. So this is the square root of 8, and this is -1.
Wait, this is. No, this is this. Oh, problem. Yeah.
So it's supposed to be sine of x over 2 and cosine of x over 2. The problem, it's not looking
Oh,
for
we're
sine
not
of
looking-
2x.
we're looking
It's
for the
looking
half
sine of x
angle.
over 2.
Oh, so we're looking for... So this is sine x over 2 and cosine x over 2?
Say that
I
part.
didn't know how to do this.
Yeah.
Somebody did. All right. So cosine x over 2 and sine x over 2. That's what we're looking for.
We still
But the triangle's right. The other given information is correct, Stephen? Okay.
say that part.
All right. So -1 squared plus square root of 8 squared is equal to the hypotenuse squared. That's 9, isn't it? So this would be 3. All right. Now, x is in the second quadrant, right? What quadrant is x over 2 in?
The first.
Yes, x over 2 is in the first quadrant. If I divide those by, I said 80. If I divide those two parameters up top, 90 divided by 2, x divided by 2, 180 divided by 2, x over 2 is in the first quadrant angle, so both of these quantities are in the first quadrant, and that's going to make their answers positive. Because remember, there's a plus or minus in the sine x over 2 identity. Sine of x over 2 is equal to plus or minus, but we're just going to go ahead and keep the plus. 1, we got them yesterday in our, did you write them down in your notes yesterday? It's 1 minus cosine x over 2, is that right? Right here. Yeah. And then, so I need the cosine of x, and we're going to keep the positive there. 1 minus the cosine of this angle, cosine of x, is the adjacent side over the hypotenuse. So that's 1 minus -1/3 over 2. And I am going to get rid of the complex fraction by multiplying inside that radical by what? 3 over 3. So 3 over 3 is going to give us the...
So you're not trying to get rid of the denominator, you're just trying to get rid of
No.
all like.
Yeah, grown up trig, we don't really worry about rationalizing denominators a lot. It's not necessary.
So it's just because you have a fraction and a fraction you have to do it.
That's correct. We are not going to leave complex fractions in an answer. It's okay to leave radicals in a denominator. It's okay to leave, as long as it's not like the square root of 16.
Okay.
But we'll take care of the square root of 16. Or 9, like we talked about a moment ago. So here we would have 3 plus 1 over 6 when we distribute the 3 top and bottom. That's the square root of 4 over 6. Square root of 2/3. That's how I would prefer that answer be given. Yeah. All right. Now, the only thing that's going to change here, if we're doing the cosine of x over 2, if we just change this to, oops, no, not that one, change this one to cosine. This becomes plus, so this would be 3,
It's still over 2.
3 minus 1 over 2, and that's going to be the square root of 1/3. for cosine x over 2. Or 1 over the square root of 3. Yeah, I mean, it's very dissatisfying because all we're doing is manipulating. We still don't know what the angle is, do we? I mean, we're just using these identities to manipulate, and it's helpful. This skill is helpful because when we solve trig equations, a lot of times we'll have cosine of 2x, and that's what we're solving for. And then so we have to figure out what x is, because in those problems we are going to take the next jump and figure out, okay, if cosine of 2x equals such and such, then 2x is equal to this. Well, x has to be this. So we're going to kind of bring this all together when we're solving trig equations in our next unit. And then all we have after that is vectors and complex numbers. Complex de Moivre's theorem. I'll show you how to find all 4 fourth roots of -2. Why not? Yes, Stephen?
For the one, like the third one on the bottom, why is it? Is that a 2 or a 3?
It's a 3.
Then 3 minus 1 is 2 though.
It's 2 over 6,
Oh.
which simplifies to 1/3. Yeah, 2 over 6 is 1/3. Okay? Time for one more? Y'all okay? Did you have any issues with like finding the cosine of 15 degrees? You're okay with that?
Can you show it? Just so.
I mean, I can. Cosine of 15 degrees.
Did we do sine 105? Oh, no, we already did that.
Sine of 105 we did in class. If we did cosine of 15 degrees, there's a couple ways we could do this, right? We could use a difference identity, and we could say this is the cosine of 45 degrees minus 30 degrees. Or we could use a half angle identity, and we could say this is equal to the cosine of 30 over 2. Yeah, so probably this one's easier. That's 15 degrees is in the first quadrant, so it's the positive answer. 1 minus the cosine of 1 plus the cosine of 30 over 2. Cosine of 30 is equal to square root of 3 over 2 over 2. Multiply top and bottom by 2, and you're good. Okay? Pretty slick to do that. It's just finding the exact value of the cosine of 15 degrees. All right?
So in that one, you would multiply the top and bottom by 2, right?
Yes, if you multiply top and bottom by 2, if we were to finish this, it would be times 2 times 2. That would give you 2 plus the square root of 3 over 4 square root. Which, 2 plus the square root of 3 over 2 if you take the square root of 4. Okay. You guys are more ready for this than you think you are. Y'all just want to start spring break
This is hard.
now instead of
Yeah,
after
that would be
Friday.
nice.
We're already taking